that means 1 month to 6 months or so, then you may ask that key accuracy of the forecast sometimes for 3 days to 7 days is not that good, and then how you can forecast for 1 month or 1 season. So I would like to clarify that the monthly forecast or the seasonal forecast is useful for the planning, then for the policymaker and government. For example, if you say that this year's monsoon is going to be a good monsoon, or we are going to get a good rainfall, so the government has uh, to have their policies accordingly. For example, if you say that this year is going to be a drought year, then policymaker government have to allocate the funds accordingly and plan the activities accordingly. So this is how the long range forecast is useful. But 3 to 7 days or short range forecast is useful for your day-to-day planning, um, then travel, and then it has application in all the sectors including agriculture. So for example, if you know that it's going to rain after 3 days, and you are going to irrigate your farm, so you can delay your irrigation because it's going anyway, it's going to rain. And it is also useful for disaster management, and it has applications in health, power sector, and so many. So, so the different ranges are there in the weather forecasting, and it has their own application. So major weather hazard, if you talk about India, we have power sector these and so many hazards like heavy rainfall, thunderstorm, coastal risks, the wind or tide, etc. Then rough sea conditions, heat wave, cold wave, fog, and tropical cyclones. And nowadays we issue color-coded warnings, and as the color becoming goes towards red, then the severity of the warning is more. So that's how it is. So color coded warning we started issuing, as I already mentioned. And then traditionally or conventionally, whatever forecast we used to give, and all over the world, so far it used to be given, it was like it used to be like fixed threshold were there. So for example, I would say that the heavy rainfall expected over the Pune city in coming days, on so and so date. So people will say that okay, it's going to be heavy rainfall. But if I say in addition to what that rainfall is going to do and how it is going to affect your life, for example, if I say that heavy rainfall is expected on 26th of July, and um, okay, then it is going to have it is going to cause the urban flooding in low-lying areas. So it will have a more direct impact, and then people going to look at it seriously. So we started giving such kind of a forecast, and it's called impact-based forecasting. And so why we have to move to the impact-based forecasting, because it is in a simple language, and it is directly giving the information about how this heavy rainfall or any weather phenomena is going to affect their life. For example, if I say that in a normal language, conventional way, if I want to say, I would say that what weather will be, then it is like 200 millimeter in 24 hours is expected, and 34 knot winds are also expected um, over the region. If I say this way, then they are not going to take it seriously. But at the same time, if you say, if you modulate that in a way that in this way, roads are going to be flooded, communication will be cut off because of the strong winds, then people will take it seriously, and it is very easy for even disaster managers uh, to take the action properly. So then question remains. For example, if the heavy rainfall is happening at plain areas, and shelter is there, building are there, good drainage system is there, then the risk, those people are not at risk. However, if similar situation is happening in the low-lying areas or in the slum areas where the drainage system is poor, so in that particular case, similar situation, but impact will be more, and they are more vulnerable. They are more exposed to such kind of conditions, and they are so we need to focus on that, and that is why impact-based forecasting is most important and effective, and we have already adopted it in IMD. So, for example, here is one example. The strong winds are expected tonight, which may result in delays or cancellation to the ferry services and keep small fishing boat tied up. If this kind of a forecast is there, instead of strong winds and expected tonight with wind speed 50 knots, this people may not take this seriously. But if you say this way, though the ferry services can be operated accordingly. This is one of the example, and people also can plan their activities accordingly. So this is one of the example, and based on the likelihood is low, in that particular case warning may be issued. For example, my confidence level is medium and the impact of that particular weather event is going to be low or minor, then in that particular case I will be issuing a yellow warning. But if my confidence about the occurrence of that particular event is high and impact it's going to have on the people is also high, then in that particular case I'll be issuing orange or red warning. And so that is how it has been adopted in recent times. So based on the impact and its probability or likelihood, the forecast warning has been updated. These are some examples that how we are issuing the impact based forecasting in the meteorological department. So this is one of the example of Gujarat flood in 2020. So there are some advisories were issued, and how stages, what there are some stages of weather forecasting, and then how this information is being disseminated. So we have got our website, then these informations are being updated on our app as well as on our social media handles. Then this information is also disseminated using common alerting protocol. I will be talking about this, and in addition to that, media and state government, through state government and disaster management managers. So what is common alerting protocol? So this is internationally accepted system wherein what happens is that, for example, if for example, weather hazard is going to affect your region. For example, it is a cyclone, and if cyclone is approaching your region, then uh, as a warning issuing agencies, we will issue the warning, and then we'll demarcate the areas or the region which is affected by this, going to be affected by this particular cyclone. Then all mobile users or the regions will get the information, and that information will have very specific, that will be a very specific information which says that what is the emergency, what is the area affected by this emergency, how should people act, there are guidelines given, then how bad the emergency be, and how sure are the expert, and what should people do. All this information goes to the common alerting protocol, and this is very effective. And one of the example of this is the Biparjoy cyclone. And during the Biparjoy cyclone, all affected areas got messages and this information. More than 2 crore people got the information and advisories about the Biparjoy cyclone uh, when it was passing through the Gujarat coast. And interestingly, the human casualties in Biparjoy cyclone was zero, and this is very effective method, and we are using it in IMD. So this is one of the example of it and how it works. So now I will talk about little about how climate change or global warming is going to affect the forecast, and what are the challenges in front of us. So as we know that climate change is nothing but the long-term change in average conditions of the atmospheric parameters for more than 30 years or so. And as we know that atmospheric greenhouse gas emission has increased many folds, and pre-industrial time it was around 200, 250, 280, 80, 90, that ppm it was. And now if you look at it is more than 400 and more than 400 or 420. And uh, as we know that greenhouse gases are very important for maintaining the temperature of the Earth's atmosphere. But if their concentration is increasing more, if it is increasing or going beyond the limit, it's going to Earth is going to warm, and already it is warming. And all these emissions are anthropogenic emissions, man-made emissions, and if that is going to happen in future continuously, then how it is going to affect the weather. So for example, if you look at if the global warming is happening in the say, it already started affecting the weather, extreme weather, and its pattern and its frequencies also started increasing. So how it is affecting, just we can have a look here. For example, just a minute. So if you look at this one, for example, if it because of the global warming and climate change, the heat extremes, the heat waves are becoming more extreme compared to the earlier days. Then wildfire events are increasing because of global warming and climate change. Then droughts, for example, as we know that if temperature increases, the more evaporation will be there, and drier areas will have more evaporation, and it's going to be drier becoming more drier, and that kind of a situation started happening already, and it's going to be there if it increases, the emission increases the similar way. Similarly, tropical cyclones, the tropical cyclone number of tropical cyclone may not be increasing, but the intensity intensity of the tropical cyclone are going to increase, or it is already increasing, and its rate of intensification is also increasing in recent time, and it is going to increase. Then heavy precipitation events, as we have witnessed many heavy rainfall event in recent times. For example, Chennai flood 2015, Mumbai flood many times. Every year, monsoon season, we experience the floods in Mumbai. Then most of the metropolitan cities in India, and these events are also increasing. It has been proven that these events are increasing in the changing climate. Floods are becoming common recent time, and then high tide flooding etc. is common when the intensity of the cyclones are increasing and they are hitting the coastal region. In addition to that, marine heat waves are also becoming more severe, and likewise. So the global warming or the climate change are affecting the weather, and extreme weather especially, and it becomes very challenging and difficult for forecasters to predict this in a changing climate. So what are the challenges in front of us? The challenges are, for example, when we give the seasonal forecast or the projections, then baseline period will have different kind of a scenario, and for then model may not be able to predict it. So we have to adapt the different methods for each, and then, for example, use adaptive forecasting models, bias correction, and integrate climate projections, etc. Increasing frequency of extreme events, that is increasing. So how can we how we can overcome this challenge? So we need to have a high resolution model and simple forecasting, adaptation of probabilistic predictions, etc. And IMD has already adapted this one. Uncertainty in large scale drivers like El Nino and southern oscillations. So improve couple ocean atmosphere models and seasonal to sub-seasonal forecasting system. This is also being updated in IMD. Model limitations in representing physical processes, and there are many. So point is, it's becoming more challenging to predict such kind of events in when global warming is happening and climate is changing all over the globe. So in this particular case, in this case, we need to improve the systems, and it is challenge. It is interesting as we are getting many new challenges in front of us, and we have to overcome that, and we are doing it. So this year's WMO Day theme is observing today, protecting tomorrow, and which means that we need to protect our tomorrow. We need to have a very good observing system, and we should have a good network of observations, quality observations, and state of the art observing technology. And IMD is fortunate to have such a good network of observations, as well as equipped with satellite and radar, but it is challenging. And this is one of the example, as you must have seen. This is one of the cartoon by R.K. Lakshman in 80s or 90s, and this is the common man, and yeah, this is a common man, and this is another person, and this is they're identifying this as a person from the weather forecasting agency, and they're saying that you must be from IMD or weather forecasting agency, since you told that there is no rainfall today, and you have not carried the umbrella, and it happened this way. Yeah, during that time the forecast was not that accurate, but with the help of technology and state of the art instruments um, and adaptation of new model, etc., IMD's forecast is best, says the United Nations audit in recently. And from this to this, the many development and then expertise, then in addition to the state of the art technology have come in. And similar example is here, the Frontline magazine in 1999, when there was Odisha super cyclone which hit the Odisha coast, and IMD failed to predict it correctly or properly. They criticized by saying that the scientific system, that means IMD's responsibility, it was to predict the contours of the cyclone, did a far from perfect job. To be able to do a better job next time around, an integrated approach to cyclone studies is needed. This was the suggestion, or this is how they criticized us. And the same magazine in 2013, when we predicted the landfall as well as intensity of this cyclone fell incorrectly, and many more later on. They said that with the India Meteorological Department, the improved models and observation system, and greater forecast skills, they predict accurately not only the intensity of the cyclone fell in, but also its landfall. And this paradigm shift has only happened because of the recent developments in all spheres. And you can check the weather forecast of your city, place, region, state, and of the weather, as well as you can check the agri-meteorological advisories on our Mosam app. And there is a Damini app developed by IITM and MOEs, that also you can see for the lightning alert. Uh, with this, I stop here, and once again, thank you very much for this opportunity. You are muted, it seems, ma'am.
Forward. And with this session, I also got to know ki it's just not the forecasting that you all scientists help at IMD, but also how it can support the disaster management teams and other preparedness. Basically, how they could beforehand they can prepare, and or during also the event, all they can see and prepare themselves in a best manner.
Yes.
Yes, sir.
Thank you.
Thank you. Any question from those participants? Okay. Just one for something my own, sir. As
Yeah.
there, you mentioned that there are few things already, like for the general public to understand. The color coded things, the impact based forecasting. So, do you think there is something more key challenges you faced while communicating the actionable forecast to the public? Like, if something more, if they understood more better, they will be able to take care of themselves during this condition in weather.
Okay.
Something more
Uh,
challenge you find?
sure. I think still public have the outreach. I think outreach is required, and this information has to go to the last mile. For that, we need to have more outreach program Otherwise, forecast accuracy has already improved significantly, and the outreach program need to be there. And then we are uh, trying to have such, for example, this media outreach program. Then through media, how we can communicate it properly. In addition to that, NGOs are need. Actually, it is not only IMD. I think other institutes, NGOs, media all need to come together so that this information can be disseminated, or this warnings or dissemination the warning can be disseminated effectively to the last mile. So that there, I think there is still there is a gap, and we are
Mm.
trying to improve on that.
Yes, thank you, sir. I also agree कि multi institution education-wise NGO and other public forums should come and understand how the IMD works, not very deeply, but yes, to have an overall idea, and they can forward the information to the last mile to more people out there,
True,
not just for during any disaster, but also for the agriculture. I have
true.
seen there is on ground key we have seen the impact of forecasting whether correct or precise on the agriculture. But then also there is something more we needed to be done on the agricultural ground. Uh,
Definitely, yes.
yes. How you think about the upcoming weather forecasting or the drones in an AI? Like I'm just making a mix of upcoming app-based weather forecasting. Are they also IMD? They take data and they just made timely providing that information to farmers, to other public.
So no, I could
The
not get it.
app-based data that
Okay, app. Okay, so agriculture. If you see, we have got a MOSM map, as I said, and there, if you go, agro-meteorological advisories are being issued there. And how it happen is that, for example, if some low pressure system, I'm just giving an example कि one low pressure कम दबाव का क्षेत्र तैयार हुआ है and it is moving in per certain direction, so that area is going to get affected. So weather warning, how we give information about the weather, and we have collaboration with Indian Council of Agriculture Research, and there are experts in agriculture, and they know exactly how much area is sown and what kind of crops are there in that particular area. And then then based on our forecast and their expertise in the agriculture, they issue uh, combined, it is a combined advisories are issued to the farming community, that these many districts are going to be affected, and what are the precautions to be taken. For example, if low pressure system is moving and your crop is at harvesting stage, and you have got 2 days, you got this information 2 days in 2 days before, so you can do that harvesting of that crop, keep it at the safe place, or you can just make it ready. So this kind of information is being issued in agro-meteorological advisories. And it's not only IMD, ICAR is our partner, so we are having collaboration with them, and this is how it is being done. So in case of other for other disasters like cyclone, etc. For example, cyclone is hitting the eastern coast. For example, Odisha coast is mm, uh, going to have a landfall. Then we have what we say coordination with Indian Navy, then disaster managers, district collectors of the area affected, etc. And then all this information is being issued through that way, and then they take the further action like evacuation of the people from the likely affected areas, and then camps, for example, etc. So all that happens this way. For example, then if extreme rainfall event is expected in coming few days, then we give this information to the district authorities, and then they take the further measures that what can be done and all that. So it is like a coordination with the other departments,
departments.
disaster managers, etc.
Yes. Yes, I got an idea, sir. Thank you so much, sir. With this, okay, we have one question, sir.
Yeah.
Just a minute, sir. Is there any criteria for extreme weathers are changing over not very in a shorter duration, but over longer duration? Can we say that extreme weather events are now changing their frequency?
Yeah, matlab, if you look at the rainfall data, for example, it's already been done and it's already there in the literature. There are scientific papers which suggest that the intensity and frequency of the extreme events are already there, and they are already increasing. So yes, they are already increasing, and we are actually issuing the forecast as per uh, what we say. The criteria is like, for example, extreme rainfall criteria is different, where we have operationally we have like heavy rainfall. If you say, then it is 64 to 114 millimeters. Very heavy is like 115 to 100 and 2,204 millimeter, and greater than 204 millimeter is called as extremely heavy rainfall,
Extreme.
etc. These are
Okay.
so these are our operational criterias. But whether what is the criteria for defining the extremes? If you ask, then we have this criteria in this one, and this whatever criteria I told, their frequency and intensities are increasing in recent time. That is already been studied.
Okay. Thank you, sir.
Thank you.
I'll check, sir, if there is any other question. That's a question, sir.
Okay.
With this, I thank you, Dr. Sanam, for this session on with the changing climate and the weather prediction, weather forecasting, how the IMD is actually supporting and people and the other team departments to forecast and prepare for the weather related events. Moving on to the next session, we have uh, Eptree with us. We'll be introducing our second speaker of the session, that's Dr. Bhima Bindu from JNTU University.
Hello.
Yes.
Yes. Is my voice is audible?
Yes. Yes, sir.
Yeah. Thank you,
Perfectly
ma'am.
audible.
Thank you, ma'am.
I'll
Thank
share.
you. A very good afternoon to all. A
I'll
warm
share
welcome.
the PPT.
Ma'am?
Can I share the PPT?
Yeah. Before you share, ma'am, I would like to introduce you to the participant. Like I'll take 2 minutes of your time. Yeah. So it's my privilege to introduce our session expert, Dr. V. Himabindu, and we warmly welcome you to the session, ma'am. And Himabindu, madam, is a distinguished academician and environmental scientist, currently serving as a professor and head Center for Environment at JNTU Hyderabad. And she holds PhD degree in chemistry and has extensive expertise in environmental management, pollution control technologies, and sustainable energy systems. And with over 2 decades of teaching and research expertise at JNTUH, and Madam has guided numerous PhD scholars and MSc students and contributed significantly to the capacity building in environmental science and engineering, and successfully executed several R&D projects funded by national agencies such as DST, DBT, BRC, MNRE, and UGC. And in addition to that, Madam has organized numerous workshops, conferences, and training programs focusing on sustainable environment and cleaner technologies and environmental management. And with this, I request Dr. Himabindu Madam to proceed with the session. And I once again warmly welcome you to the session, ma'am. Over to you, ma'am.
Okay. Thank you for introducing me. So,
Yes.
thank you for giving me this opportunity. So, I would like to share some part of the work what we are doing in our laboratory. That is the enhancing energy recovery from wastewater treatment plants. So, particularly, this is a sewage wastewater treatment plant. So you have both aerobic type of treatment and anaerobic type treatment. So when you do for anaerobic upflow and a sludge blanket getter, anaerobic treatment, you can get the energy recovery. But so we can treat that sewage sludge with the help of anaerobic digestion. So with a raw sewage, when you do anaerobic digestion, so it is not easily degradable. So the raw sludge gives the energy, which is minimal. So how to improve that energy from the sewage sludge, the energy recovery from the sewage sludge with a prior treatment. So this topic is dealing with a thermal hydrolysis process. So through thermal, because the sewage sludge, it is containing mostly the microorganisms. So in that, it will contain organic and nutrient content. So you can, if you can recover more energy from this organic content and a value-added product like a nutrient, it will be attractive. Because many of the STP plants with aerobic treatment, lot of energy you need to invest in the aeration. And in anaerobic treatment, you can reduce the energy input, like in anaerobic treatment, like UASB reactor. But in aerobic treatment also, you'll get lot of sludge. So the microorganisms generation is more when compared to anaerobic. But the sludge generated, we should dispose it. So you have to most of the processes, they do dewatering of the sludge, and then they use some type of filter press or belt press. Then they will dispose it to the farmers. So they apply directly to the land treatment. Sometimes they do some composting. But with this, the energy what most of the treatment plants are around 300 MLD and all. So they are spending more than 1 crore of rupees for electricity charges for aeration. So how to make like recover some energy from this sewage sludge? So in that, normally the wastewater treatment plants, they do sludge digestion. That is not reaching not the 100% recovery of the energy from that sludge. So here, a hydrolysis treatment, it increases the soluble COD or BOD, so that it will, the bioavailability of that organic content will be more when you do hydrothermal thermal hydrolysis treatment. So that is what it has been taken up in this study. So how to recover more energy from the sewage sludge. So particularly the anaerobic sewage sludge, the sludge contains carbohydrates, proteins, and fats. So the first step is hydrolysis. This is the rate limiting. So it takes time to degrade the carbohydrates, proteins, and fats into fatty acids, amino acids, and sugars. So it is a rate limiting step. Afterwards, the acidogenesis will take place and then produces like the carbonic acid and alcohols and hydrogen and CO2 and ammonia. Then acetogenesis process will convert them into the fatty acids. So here the CO2 and H2, the methanogens will convert them into methane and CO. So this is a normal anaerobic digestion process. But here we will involve in this step through thermal hydrolysis to improve the content of the more sugars and all. So so that you can get more organic content is available for energy. Another aspect is there is an chances of obtaining phosphorus out of that thermal hydrolysis process, because when you do thermal hydrolysis, cell lysis will happen and then the phosphorus will be dissolved in water. Thereby, the phosphorus accumulated in water can be precipitated or you can use it as a liquid fertilizer also. Okay, so the phosphate is another thing, is it is a finite critical raw material, and we were importing almost 80 to 90% of the phosphate we were importing, and now because of the intervention of recovery as many as possible resources, it has been come down to 50 to 60%, the importing of the phosphorus content. So already the Europe and all, they have initiated how to, they've enacted some of the rules like, so how to utilize most of the sources from sewage sludge and poultry and dairy and so many of the places, whatever the chances are there to recover, so they are all taken up with the initiation, and then they have an organization, European Sustainable Phosphorus Program. So under that, they have initiated these type of activities with the stakeholders. So even under the sustainable goals of goals under 12, this type of recovery of energy, reusing of energy from the sludge is also an essential thing. And even the under the Montreal Global Biodiversity Framework, so the nutrient recycling is also an essential area. So both it can meet this study. So here the methodology is, if you take the sewage sludge through thermal hydrolysis, and after the thermal hydrolysis treatment, if you go for anaerobic digestion, you can recover the biogas and biosolid. So here, after thermal hydrolysis, the liquid can be utilized to precipitate the phosphorus in the type of struvite. This is the thermal hydrolysis reactor. So where we have taken up the sewage sludge of 500 ml and 30 minutes at different temperatures we have studied with at different temperatures like 160, 170 and 180 degrees. So at what temperature, it is optimum for a soluble COD, increasing in the soluble COD. Okay, so then after the pre-treatment, the sludge was collected from that, and then it has been subjected to anaerobic digestion. So the pre-treated thermal hydrolysis sludge is inoculated with anaerobic sludge, and then so we have it has been avoided like purged with nitrogen to remove the oxygen content. So then the whatever the gas, it was collected through water displacement system. And then the gas was analyzed using a gas chromatography system. What is the methane content and CO2 content? And this is the Stewart methodology. So where after pH adjustment, then we have added, because it contains phosphates, when you add magnesium and ammonium salts, so the consideration is you have to maintain the molar ratio of 1:1:1 of magnesium and ammonium and phosphate. So with the help of the reaction time between 10 to 16 minutes, so the struvite is precipitated. So this is the sludge, the characteristics with the raw sludge, as well as different treatments after 30 minutes of treatment at 160, 170 and 180. So here the pH variation is slightly varied, but total solids has come down from 64,000 to 49,000. And the TDS, dissolved solids, were increased because solubility of the sugars and all will increase. So the TSS has come down, and then nitrogen content has been increased because the nutrients have because in the sludge. So then availability, then sulfur, and then ammonia. And soluble COD almost in the liquid water has been increased to 600 to 9,600, 16,000 and 18,000. And then the rest of the inorganics also increased because from the sludge it has been gone into the liquid. So then these are all the moisture content, percentage of volatile matter, fixed carbon. They are not in the liquid. These are in the sludge, whatever the sludge it is there. So in that, so when you dry it and then when you pursue the acid content, it has been come down because some of the percentage of the ash, volatile matter and fixed carbon has gone into the water. Okay, so the residue in the phosphorus also increased the nutrient, and volatile solids are also from 67 to increased to 79, 790. So the similar thing, it has been shown in the plot at different temperatures. The soluble COD, this is the responsible one for the gas production, and the phosphate was also leached into the water. They've also the ppm was raised with the increase in the temperature, but at 180 degrees there was a decrease in that. This was optimum temperature was observed at 170 degrees. And when you observe at different pHs, the anaerobic digestion, so at pH 7, it has shown the with the increasing from 5 to 7 into pH. So there was quite increase in the methane content. And even at the different treatments, so almost like a slight variation at 160, 170 and 180 little decrease we can observe in the methane generation from gram of volatile solids. Then, so the maximum yield, it has been reported like the methane yield of per gram of VS has been taken at pH 7, it was 205 ml. And when the temperature is raised, so the content was increased by 54%. That is 205 was observed at raw CD sludge, but it was enhanced to 316 when it is in 170. So like the energy balance study was taken up, like we have invested the energy for thermal hydrolysis. And after investing the energy incurred, then what will be the energy final energy balance recovery when it is calculated with the help of this equation? So density of the sludge and volume of the sludge and specific heat capacity and the initial and final temperatures. So then when you consider that the energy which is given for thermal hydrolysis is 19 megajoules, and the output energy after the thermal hydrolysis, so the energy is 38 megajoules. So there is a net energy production after the thermal hydrolysis is 19 megajoules. So per ton of dry solids. So based on this study. So like it is, and not only the advantage of recovery of phosphates, because of the thermal hydrolysis, the pathogens will be killed, and you can produce class A sludge also simultaneously. Directly, you can apply, you can use it for land applications. So class A sludge production, the nutrient recovery, and enhanced energy recovery. So all these three things can be possible. Not only that, you can recover some of the proteins and other value-added products also in this method. They are under the study. So this is the outcome of the present study. Still studies are going on in this direction. So any questions, please? Thank you.
Thank you, ma'am. Thank you for sharing your valuable knowledge and professional experience and providing insight into how these energy recovery processes are aligned with the global SDGs. And this is, I request if anybody has doubts, they may write it in the chat box. Anybody has any doubts, they may raise your hands.
Yes, one thing I want to ask. Thank you, Bindu ma'am, for such a good session. It was a new concept for me also to understand that we can recover energy from wastewater also. So I'm just thinking ki we yet are in our country, we are still going on energy, waste to energy of the burning of solid waste. Getting energy from wastewater is a very new concept. So how you think like what will be the main barriers to see it getting for out of a lab based research from institution to somewhere and on practical in ground, some adopting this kind of technology, how this would be useful and where it can be started, like what kind of support we will be needing to make this concept out of a lab to the field.
So, like in abroad in Netherlands, there is a combi technologies there and practicing that. But because you need to have a continuous system is beneficial because in India the hydrothermal reactors are in batch type mode. So when you do batch type mode, most of the times the energy will be loose because after the one batch study, you have to lose the pressure, temperature, everything. Again, you have to start the reactor. So, but if it is a continuous reactor, so the technology need to be developed for a higher capacity for a continuous reactor. Thereby, without much loss of energy, you can do this thermal hydrolysis process. That needs to be improved. There are imported one power reactors and all, but very expensive. But when you examine the energy balance, still almost like huge energy can be saved after thermal hydrolysis. And particularly the class A sludge production is also important because you are killing the pathogens without any disinfection process. And simultaneously that is suitable for land application, the sludge further after energy recovery. So you simultaneously nutrient recovery is also one of the possible way. So you have to show that one is technology development, continuous thermal reactor, thermal hydrolysis reactor is one of the limitation factor here. Indigenous technology should need to be developed, continuous thermal hydrolysis reactor. And other things we have to show what is the ultimate economical benefits through recovery of nutrients as well as the production of class A sludge and the production of energy.
Yes. Thank you, ma'am. After the treatment of the energy recovery from the wastewater, we still need to do some kind of treatment
No, this is
to
not
make it land application.
Actually, this is not for the wastewater. So the sewage water will be treated with bacteria. So the bacteria, after the growing of the bacteria, you have to dispose that bacterial sludge. So, so from the sludge. So energy recovery from water is one aspect. That is anaerobic treatment will generate some of the energy. That is one thing aspect. The second aspect is the sludge which is generated during the wastewater treatment process, the microbial growth. So because there is a residential time of the bacteria, so then after that they will die. So you have to dispose that sludge frequently. So that sludge disposal, normally you have to dewater it and then you will belt press it and then you will supply to the farmers for a composting. After that, they will apply to the land. That is the process. The sludge, bacterial sludge, they will solar dry it or they can do belt press. They can dispose it to the land application. But in that process, the energy, what you are spending for aeration of the wastewater, that is very huge amounts of electricity, amount for electricity they are spending. So some type of energy recovery should happen from the wastewater treatment plants. In that way, the sludge generated can be utilized for energy generation. That is already in place in some of the places, but not attract. The energy recovery from wastewater is one aspect. Energy recovery from the sludge generated from the wastewater treatment is another aspect. So, but it is not attractive now because the raw sludge is not amenable for biodegradation so fast. And then if you go for and not completely. So if you go for a thermal hydrolysis process, it will enhance the energy recovery so that you will get some of the energy costs. You can recover some of the energy costs spending on wastewater treatment.
Okay, ma'am. So it's supporting the fecal sludge management that is also.
Yes. But studies like fecal sludge, normally anaerobic digestion can be done. So instead, if you go for a thermal hydrolysis process, more amount of organic content, soluble organic content will be available for the bacteria. So you will get the more energetic.
Okay.
So only thing is, it is like a cooking process, like the thermal hydrolysis.
Okay.
So that if you do it in a continuous reactor, more beneficial.
Okay, ma'am. So it's a kind of circular practice also,
Yes,
the waste.
you can
Yes.
recover the nutrients. When
Okay.
you separate the solid and liquid, so most of the nutrients from the solids will coming into the liquid. So that
Ah.
you can recover as a liquid fertilizer, or you can precipitate as a steroid.
Okay. Thank you, ma'am. Thank you so much.
So shall I leave
Thank you,
or
ma'am.
any questions?
Thank you, ma'am. Over to you, Simbi, ma'am. Like, would you like to say some? To propose
No,
what
sir,
is
that's
something?
okay from my side.
Okay.
We have planned for a mission pledge from sir your
Yeah.
side. Yes.
So if
Thank you, Bindu ma'am.
Okay, thank you.
yeah. So now I request all the participants to, repeat after me. Like it's just a mission life pledge. Like, so hope my voice is clear and audible.
Yes, it is all.
Yes. Like, please repeat after me. Just, I pledge to make all possible changes in my daily life to protect the environment, and I also commit to continuously motivate my family, friends, and other about the importance of environmentally friendly habits. So, is there any possibility to, turn on their videos, ma'am? Like, we were not able to open our videos, video cam.
Okay. So,
So that we can take a group picture with all the participants. I thought of.
uh, you want all of us to switch on their video
Yes,
for,
yes, yes.
okay. Requesting all participants if they can switch on their video for a minute so that we can have a mission pledge as well as a photo for the session, for the session.
So hope, okay, we can proceed with this, ma'am.
Yes. Does you have made that pledge now?
Yes. Shall
Yes.
share
Mm.
to one? Yeah. Hope it is visible.
Yes, sir. So yes, it's now visible. We can.
Yeah, ma'am. Hope my screen is visible now.
Yes, yes, it's visible, and we can also share that since it's also streaming on YouTube channel. All the participants there, they can comment as I pledge, and
Okay.
yeah,
It's a good thing.
yes.
I pledge to make all possible changes in my daily life to protect the environment, and I also commit to continuously motivate my family, friends, and others about the importance of environmentally friendly habits. Like after this, all the participants who are listening to this, they may share their feedback on YouTube and also to reach out to respective email IDs. Thank you.
Thank you.
Shall we
Thank you,
conclude?
sir. Yes, sir. With this, we end our two sessions on meteorology and water. And I would like to invite now Ritik for a vote of thanks. Uh,
Am I audible?
yes,
Yes.
Respected dignitary. Hello.
you are audible, Ritik.
Okay. Thank you. Thank you, Dr. Sanfi. Respected dignitaries, esteemed speakers, organizers, and all participants. Good evening to everyone. On behalf of organizing team, I would like to extend my heartfelt gratitude to all for making this virtual expert come interactive session a great success. First and foremost, I sincerely thank you, our distinguished speaker, Dr. S.D. Sanap sir, from the India Meteorological Department, Pune, and Dr. V. Himabindu for sharing their valuable knowledge and insights. Our expert talks on the significance of weather prediction in changing climate and enhancing energy recovery of wastewater treatment plants. We are truly, we are truly enlightened and have provided us with deeper understanding and inspiration. I would also like to express my sincere appreciation to the Indian Institute of Tropical Meteorology EICP team and EPTRI team for organizing this meaningful session. Your continuous efforts and promoting environmental awareness and capacity building under the Mission Life campaign are highly commendable. A special thank to all the participants for all enthusiastic involvement and active participation. which made this session more interactive and impactful. Thank you. Thank you all.
Thank you.